Let's talk about hypothesis testing for the mean for one population when the population standard deviation is unknown. We're going to solve these problems from Newton using RGuroo. We have an automobile manufacturer claims that the gas mileage on its new model of hybrid sport utility vehicle, it's 40 miles per gallon. The consumer group test this claim by providing a random sample of 20 of these hybrid SUVs and recording the gas mileages. These mileages are shown below. We have them in this table. Okay. We're going to use RGuroo to test whether the mean gas mileage is different from 40 miles per gallon, and then draw a conclusion in the context of the problem, and we are using a significance level of 0.05. So then we need to choose from here which one is the correct one. So let's go to RGuroo. Well, before going to RGuroo, we need to download the CSV. And then I am going to RGuroo, I am going to data and import this data set into RGuroo. So we choose the file. I always change the name to make it easy to find it. Right? It's always going to give us like the summary of the data set. So we're going to analytics, we're going to analysis, mean inference for one population. We are going to select the data set. We're going to choose our variable, right? Everything is going to be filled for us. So the sample mean, it's 38.76. The sample standard deviation is 1.94, and we have a sample size of 20. We don't know the population standard deviation, so we don't have information to put in here. That's perfectly fine. We don't know the standard deviation, then we do a t-statistic. So I'm going to choose the t-statistic in here, just to include the confidence interval in the output. All right, significance level is your alpha, and that is 0.05. The alternative, we are going to test whether the mean gas is different from 40 miles per gallon. So different is no direction. We can go both ways. So when we go to RGuroo, the difference is just the not equal to sign, which is the exclamation point with the equal sign. So then different than 40. So mean, it's different than 40. And again, we keep the same method as the confidence interval. We don't know the standard deviation of the population, so we use the t-student distribution to calculate our critical value. All right, so once we have that, we click in here and we get our output, right? So our output includes the t-based confidence interval. So confidence interval goes from 37.85 to 39.67. So we have our tails, the two tails up and down. And so we have in here a p-value of 0.0102. So when we have that, the p-value is smaller than the alpha. So we have a p-value of 0.01. Is less than alpha equals 0.05. So we do have the evidence to reject the null hypothesis. So we reject the null hypothesis. It's either this one or this one. And we say that there is sufficient evidence to conclude that the mean is not equal to 40. All right, let's move on to the next problem. Same type of problem. So we're going to do the same thing. So I'm going to download this CVS. I am going to upload the data to RGuroo. So it's the first one. I'm going to change the name. I'll do time to complete game. Upload. All right, so I have it in here. I'm going to use it in a minute. So Ross has created a puzzle game that he believes will take 30 minutes for a player to complete. A week after the game's release, he collects data from a random sample of 20 players on how long they took to complete the game. So we have the time in the table right here. We're going to use RGuroo to test whether the mean time to complete the game is different from 30. We're going to draw our conclusion with an alpha of 0.05. So again, I'll go here, analytics, analysis, mean difference, one population. I'm going to choose my data set. I am going to choose my variable. Everything is going to be filled out for me. We don't know the population standard deviation. So when we don't, we have a significance level of 0.05. Our alternative hypothesis, again, is different from 30, and I have it highlighted in my problem. We do a t-statistic because we don't know the standard deviation of the population. And if we want our output to choose the confidence interval, then we just click in here. It's 95%. This is the difference in between 1 and 0.05. We click in the I, and here is our output. So we have the confidence interval in here, our lower, our upper, and then we have our test statistic is this number in here if you need it. This is your critical point. And then this in here is our p-value. So 0.09, it's bigger than 0.05. P-value is bigger than alpha, then we fail to reject the null hypothesis. And when we fail to reject the null hypothesis, it's because there is insufficient evidence to conclude that the mean is not equal to 30 minutes. We don't have enough evidence to support our claim. So the last one is going to be the response for this one. All right. One more. It says an information technology help desk has a service legal agreement that says that clients should be contacted about their service requests within an hour of the help desk receiving the request. Jackie, the help desk manager, wants to check if the help desk is actually taking longer than 60 minutes to respond. For a random sample of 20 service requests, Jackie obtained the time between the help desk receiving the request and the client being contacted. The marketer conducts a one mean hypothesis test at a 5% significance level to test whether, again, here's your testing, here's your claim, to test whether the response time is greater than 60 minutes. When we are working with the hypothesis, you are testing something against 60 minutes. So then your null hypothesis needs to be that the mean time is 60 minutes. And your alternative hypothesis needs to go with your test, with your claim. So it cannot be this one, right? It can't be this one because here is the mean is less than 60 and we want a response to be greater than 60. So then it should be the last one. No hypothesis is that the mean time it's equal to an hour, 60 minutes. Then the alternative is your claim that the mean time is greater than 60. It's a right tail, it's giving us direction, right? So once we have that, I'm sure he's going to give us the data to test, to perform the test. So I'm going to download the CSV. I am going to upload that to RGuroo. So this is, let's just call it service request. So now that we have the data, we go back here. I'm going to open the service request data set. It just give it a random number because we don't have anything in here. Oh, okay. Let me see if I can fix this. Let me go and open the data. It doesn't have any, let's see, I'm going to do it again. All right, so here, I'm going to do it again. This is the first time it happens to me. So I am glad that it did. Let me just call it service so that I can, right? So if you look in here, your data set doesn't have a header, meaning that like it doesn't have a cell with the name of the variable. So then in here, the header doesn't exist. So I'm going to do no header and I'm going to upload. Look at the difference now between the one that we had before, which is this one. You see how it took the 62 as your name versus this one that it just called, you know, v1 variable 1, and you have all of your 20. All right. And I just noticed that when I did this, because here you see I have a sample size of 19 and it's actually a sample size of 20. So then I'm going to change this and I'm going to take my service and v1, and now sample mean is 60, standard deviation for the sample is 1.69, and I have my sample size of 20. Now it makes more sense. I'll do the test statistic. I'll just click in here for the confidence interval. It's a significance level of 0.05, and then we are going to test whether the response is greater. So then here we go greater than 60. And it's a T again, because we don't know the standard deviation of the population. We click in here. We need the test statistic and the p-values. Okay, again, so the observed T-stat is your test statistic. So that is 1.71, and we need to round to 3 decimal places. So 1, 2, 3. Next is a 5. So then I round to 6. And then the p-value, I just take more than 3. And then I need to use 1, 2, 3 decimal places. The next one is a 2. So then 25 goes. All right. So again, once you do that, this in here, this observed T-stat is your test statistic. And then this in here is your p-value. All right. So let's continue. Last one is for me to conclude. So then I have a p-value of 0.05125. This number is bigger than the alpha, just a tiny bit, but it's bigger. If I compare 0.051 to 0.05, the p-value is bigger. P-value bigger, we fail to reject the null hypothesis, and we fail to reject the null hypothesis because the data do not provide sufficient evidence to support my claim of average response time being greater than 60. All right, again, this is homework 9.4.5, and I hope this video helps you complete the homework and understand hypothesis testing for the mean when the standard deviation of the population is unknown.